How long does it take a bullet to reach its maximum height if you shoot it all the way aiming straight up to the sky? Or how long does it take for the bullet to hit the ground again? Those are questions that we can solve them using kinematics, and that is exactly what we're gonna do today. So now, one of the most important things that we need to know when we're trying to find the maximum height a bullet will reach when we shoot it all the way up to the sky, it's gonna be the initial velocity. Just a quick Google search will give you that most bullets go out of the firearm at 1200 meters per second. This is their initial velocity. So now, how do we solve this problem? We know that a maximum height is the point where the velocity is zero. Because objects, we know they follow a path like this. When they get to this point, that is like when they just hold still, they're like levitating to some extent, you could say, because they go like, ooh, and then they hold it, and then they go down, okay? When they hold their position in that maximum point, that is when the velocity, or you can say final velocity, if you see it with respect to your initial position, is equal to 0. So now we need to find an equation that gives us that final velocity, in which we know that when final velocity is equal to 0, there is a specific amount of time associated with that velocity. Okay? Just to see what I mean, let me show you this. So we know we can calculate final velocity as this equation. So remember, in the derivation of the quadratic equation for the displacement function, remember you can say displacement is a function of time, there is this equation right here in which we know that final velocity is equal to your initial velocity plus the change that you need to reach that final velocity, which is just acceleration times time. So in this case, what you need to do is the following. We know final velocity would be equal to 0, its highest point. Initial velocity, we know how much that is. And now, do we know how much acceleration is? In this case, we do, because we're on Earth. And acceleration would be equal to gravity, or the same as 9.8 meters per second squared. So now we can substitute in that value. And now the only thing that we need to do is to solve for time. So I'm just going to, just play the algebra. You would have negative 1200 meters per second is equal to, I'm just going to, divide both sides of the equation by gravity, so I can isolate time. Square, and this should be equal to time. Now, cool thing about physics is that in this case, these two seconds, the units of seconds, if you screw up any notation or any mathematical method, you might get that time, for example, is negative, and time cannot be negative. For example, let's say that I forget that I need to switch the sign when I move this value to the other side. I would get that this is positive. And in this case, that quotient would be a negative number, and time cannot be negative, okay? So in physics, if you see that something doesn't make sense, probably you screwed up any mathematical process before getting to that value. So now if you plug out your calculator, you're going to find that this sweet value is going to be equal to, let's see it, minus, never mind, it can be minus, yeah, I read it wrong, yeah. 122, I'm sorry. I was talking about time can't be negative, and then I say minus. No, it's not minus. Time is equal to 122.44, I'm just going to say 0.5 seconds. Cool. Now, why is this information necessary? Well, we're going to use our pretty sweet function, displacement function, you could call it, which is the following. This sweet equation, pretty much everyone knows it if you've been doing some kinematics. So we have the values we need. We just need to find displacement. We know how much acceleration is, we know how much time is, and we know our initial velocity. So let's find it. We know a is equal to 9.8. Divide that by 2. that would be negative 4.9. Negative 4.9 meters per second square times, we know this value right here, 2.5 seconds. I forgot I missed the seconds, but it's time. It's the term that is squared. So this is time plus our initial velocity, which in this case it's positive. Okay, you gotta be very careful with the signs. Initial velocity is positive because it is going in the upward direction. We have 200 meters per second times time. And we know how much time is. We know it's 122 seconds. Okay. So now let's see what calculator gives us. Okay, how much is this? And so we get that displacement is going to be equal to a pretty big number, 73,469. I mean, to forget the decimals, meters. Now you might be wondering, isn't this a very big number? Of course it is, but well, we're assuming a resistance does not exist, and of course if you shoot a bullet straight to the sky, of course air resistance has a very big effect in the path the bullet will take, and of course in the maximum height it will reach. So now this value primarily shows how air resistance actually plays a big role in situations like this, but for now just leaving it in terms of kinematics, this is actually a correct value. For a very, very large initial velocity, you're going to have this displacement when you have conditions like, well, of course, Earth's gravity. That's an awkward pronunciation. But yeah, that's what you get. So now the next question that we had: how long does it take the bullet to reach the ground? Now this is a pretty simple question. Remember that in this case we're doing one-dimensional kinematics, so we're assuming that the bullet will go up and then it will go down the same line it went up. So that means that when is displacement equals 0? So that equals 0. So that's pretty simple. We just need to solve this equation with s equals 0. So we're gonna have acceleration half, we know how much that is, times time squared plus 1200 meters per second times time. Now how much is time in this equation? This is just a quadratic equation in the form that you have for 9. I'm going to say x squared just so you see it probably better in more common math notation. T. Well, I said x, yeah, I'm sorry. Now actually, yeah, let's keep it up with t. Yeah, why not? We're doing physics. So t squared and t in here, and all of this is just equal to 0, okay? Now this is the equation that we need to solve to find the value that we're looking for. Now we're gonna use the quadratic equation real quick. So now let's do it. We would get that time is gonna be equal to minus b minus 1200 plus or minus square root of b squared. 12 is squared, that is 144. Just add 4 zeros then. 44 and 4 zeros. Well, no, actually, no, the comma, the apostrophe wouldn't go there, yeah. Minus 4ac, so we would have 4 times, a in this case is negative 4.9. I'm going to assume this is just simply 5, so I can just write, I'm going to write 5, so I can then just take the product as 20. So approximately 5 times c, we have no c, cool. So we have this equation right here, times 2a, we said it was 5, so we get negative 10. Sweet. And now how much is time? I'm gonna use the calculator now for the big numbers. So how much is that? We know this would be, I'm just gonna write the entire thing, 144, yeah, plus 20. This would give you, I believe, a perfect square. I mean, just in terms of these first 3 numbers, you should get 64, well, 164, which, well, 64, 8 squared, maybe you get a perfect square. So let's see it, minus 10, so let's see how much is time. So now for positive time, in this case, if we use the positive value of the square root, we're gonna get a pretty weird number, which doesn't really even make any sense. We're just gonna have negative 8.3, apparently periodic, not periodic, times 10 to the minus 4. And this, well, makes no sense because time cannot be negative. Now, if you plug in, however, a negative sign for the square root, oh, you get something that actually makes sense. For the negative, you're gonna get 240.000, just so you see how accurate this is, or how, well, I don't know, maybe factual this is. This was seconds, and this is also seconds. So what answer are we looking for? Clearly this one. The bullet, if it has an initial velocity of 1200 meters per second, will take 240 seconds to reach the ground once again. So now it's pretty cool, and it almost shows you that it is twice the time it takes for the bullet to go up, which is what would make sense, right? If you have a parabola, which is the path a object takes, technically, if you divide this by half, you should get, in terms of time, the same amount on both sides. And this makes sense. It's not the perfect half, but it's almost the perfect half. So this is the value we're looking for. Also, the decimal places show you that, well, this value might be quite big. Well, it's actually a true value because, well, we're not taking into account air resistance. So I hope you guys enjoyed this video. Now, well, if someone asks what is the maximum height a bullet can get, or well, can reach when you shoot it all the way up to the sky, well, now you know it's gonna be, if you don't assume air resistance, as physicists most times do, is going to be 73 kilometers or 73,000 and some more meters all the way up to the sky, and it will take 240 seconds to reach the ground. So I hope you guys enjoyed this video, and see you in the following one.